All right. Well, it's great to be here. It's been an exciting couple days, so I'm thrilled to talk to you guys today about leveraging human computation and machine learning to understand data. So let's jump in and reflect on this beautiful image for a moment. This is exactly how we're going to build the new system with this very gigantic wheel here. So, I think it's important to kind of take a step back. We've heard a lot of amazing stories about things going on that many of you are up to with respect to the data. But a lot of times, we think about terms like data and data sets. These are really clinical, almost sterile terms. They don't do justice to what this data really represents. After all, this data, it's all about sort of how we as a society move, in the form of transportation data sets. It's about how, some of us in our society harm others, in the form of, crime data. It's this represents how many of us help others in the form of 911 data, policing information, fire information. So this data, it's living, it's important, it's a lot bigger than, these clinical sterile terms that we throw around. So, what does it mean to understand this data? Before we get into, the mechanics of how we go about it, the first kind of reasonable question is why bother? Why do we want to? And I think, the way I look at it, I'm a machine learning guy. I look at a lot of things and think they're just gigantic learning models. And so it shouldn't be a big surprise that I look at everything that we're up to as just one gigantic learning model, right? It's not just about, one geek, with a data set trying to build a particular model. It's like, how does it all kind of fit together? And so to me, I think an analogy that I find really helpful about why we're all sitting here today is, imagine, for a moment, a mother or a father with their child, right? So this is kind of scenario A. They're with their child and they're teaching them a little bit of language, right? So they've got some words. You're talking about, hey, this is, giving them some vocabulary. You're sort of teaching them a language. And then you have sort of scenario B where you've got, a bunch of kids. They have this other scenario where they're kind of learning in isolation, but in addition to that, they're now they're cruising around, they're interacting with one another, they're talking to one another, they're trying out these new words. For those of you who are parents, you've experienced this, and the question we can ask, which is, under what scenario is the child going to learn language? And I think the answer is both, right? Because after all, my wife and I, we raised our kids bilingually. So our kids, we taught them our native language of Punjabi from northern India. And, they can speak, they can read, they can write. They've had virtually very, very, very limited interaction with other kids, right? They're in the scenario A for the most part. And so when we go, we were back in India this summer, and, they're suddenly surrounded by their cousins, and they're running around, and everybody's talking like crazy. It's pretty obvious who really understands the language and who really knows the language well, right? So clearly, like scenario B, collaboration is really important. So when we think about learning at this kind of, on this global scale, right, any one city can sit down and, and grab their data and analyze it and come up with correlates and predictive models and, and meaningful insights, and they will have successes. Like we see these successes, right? Like Chicago, New York, they're doing amazing things. There's no question about it. But scenario B is where, folks are sharing and they're interacting with one another, and the insights are being shared, the models are being shared, and we're building a platform, that sort of, it makes that happen that much quicker, right? It's like really fostering that interactivity. And in the same way that those kids master language on a much more kind of intuitive level, in a similar way, we kind of collectively, as governments and private companies and anyone who's trying to understand this kind of rich fabric of our lives represented in this data, are going to just be able to learn much more and gain more insights. So let's dive down a little bit deeper and a little less philosophical, and let's say, what are we really trying to get after? I mean, ultimately, we're trying to get after these kind of aha moments, these insights, right? So if we think about, yesterday, Saf gave a demo, and there was this nice kind of periodic chart that we saw, with respect to crime, and we saw this clear correlate with weather, right? So warm weather, great time to go commit crimes. Cold weather, maybe let's play Xbox, and smoke weed or something. I don't know. I don't know how it works exactly, but I don't think it's, but there's clearly, there's some insight there, right? We talked about rats yesterday. You might have thought that you learned all you wanted to know about rats, but it's actually not the case. We're going to talk more about rats today. But you know, it turns out when it's really cold, rats die. And when it's warm, there's more rats, right? So weather has, you know, plays a key role. And so those kinds of insights are helpful. There's, you know, even more important insights that we can glean. So what's kind of helpful, you know, in kind of increasing the pace at which we can glean these insights? Well, we think an improved user experience plays a big role, right? Yesterday, SAF demoed, you know, this user interface that didn't just take, you know, kind of a flat tabular data structure that's, you know, absolutely perfect for somebody like me. You know, I love geeking out with that kind of data, and many of you. But the reality is most of our customers, you know, most of our customers' customers don't really want that, right? Like a lot of the end citizens, they want something, you know, more interesting. And so we found that like fusing information from different sources, taking maps and putting them, you know, and kind of creating some kind of context for that information is really helpful. So, you know, that's one example of an improved user experience. There are other examples of what becomes possible when we understand the data on a more intuitive and richer level. So let's talk about comparisons a little bit. You know, being able to, you know, empower comparative analytics. You know, this is important. Being able to, you know, Saf talked about being able to like figure out how much park benches cost in like, you know, a city of pure size, of a comparable size or makeup to yours. Another example, you know, being able to, you know, understand like what kinds of insights are possible, you know, that are, what kinds of insights particular cities are gleaning. So I'm going to give you, so let's talk a little bit about recommendations. So once you can understand data sets and the annotations below them, certain things are possible. So for example, imagine you have, you know, a blog feed somewhere on your site, or you've got a bunch of kind of texty information where you're talking about stuff like parking and regulations and, you know, around parking. Wouldn't it be cool if you could take, you know, some kind of like a simple outreach interface that you could put on, like a widget or something, that automatically kind of bubbles up the most relevant contextual data sources so that somebody can come and grab them. Search and discovery is really important. So one of the things that we're trying to do with the Open Data Network is pair up consumers of data, meaning like, you know, application developers, with the providers of the data. So, you know, if I'm a developer and I'm building an app, you know, all about infectious disease, you know, in, you know, the city of Atlanta, Georgia, I want to be able to find all the data that has to do with infectious diseases in the city of Atlanta, Georgia. It's not really, you know, it's really basic. I need to be able to find the data. And I need to be able to find it not just at the data set level, but, you know, it might be that stuff to do with that locale is, you know, somewhere inside of a data set, so I need to be able to do that too. And so I'm going to show you some work that we've done there. Correlations and predictions are really, you know, kind of powerful as well. So I'm going to tell you a little story about the city of Chicago. In the city of Chicago, they have rats. And so for those of us who live in, you know, places like Seattle, you know, we don't have rats like they have in Chicago. I actually lived in Chicago, and when I went to college there, and they are the size of cats sometimes. And we used to sit out in the alley, you know, and for fun we would chase the cats around with remote control cars. So it's, you know, it's a real problem. It's bad. But you know, so the city of Chicago, you know, has like all of us, right? Not just government entities. All of us have a fixed amount of resources that we can allocate to a given problem. And so the question becomes, how can we, you know, more judiciously and more effectively and more efficiently allocate those resources? So in the case of Chicago, they have, you know, trucks that go out. They have a limited number of people driving these trucks, a number of trucks, and a limited number of baits. You know, these kind of little traps where you put them out and you get rats to kind of crawl in them, and then they disappear. So they ask themselves, like, hey, you know, if we just randomly put out these traps, you know, is that the best allocation of resources? And so it was obvious from just a cursory pass of the data that that's not the case, right? We saw this yesterday with this map of rat density. So then they said, well, you know, we can, so then they went and they kind of went off and read the literature, and they said, well, gee, you know, it looks possible to predict where, you know, what's causing sudden, like, it's possible to predict when a bunch of rat population is going to increase. And so they said, well, we're not interested in academic knowledge or, you know, necessarily, let's call it playbook or codebook knowledge that tells us like what's correlated. We want to operationalize this, right? We want to be able to actually save the money and most optimally allocate these resources. And so then they went out and they built a prediction model. They collaborated with Carnegie Mellon University. They built a pretty intriguing a model that's going to be made public pretty soon. And you know, it's really kind of a powerful thing. And they've been able to take, you know, and other cities, you know, are doing a lot of innovation like this too. New York's one. Cities are able to, you know, anytime you see the word kind of inspector, you know, the question is like how to best send out that inspector. You know, like restaurant inspections, you know, is an example. Do you want to send out your inspector just anywhere, or do you want to send them where there's the highest probability of a failure? Right? So those are all kind of examples. Now the question for us becomes like, how can we make it possible for Davenport, Iowa, or some of these like really smaller places, you know, that maybe don't have the money for teams of statisticians and, you know, fancy data scientists and, you know, to really kind of dig into these problems. Or maybe they do, and they just want to be able to do things better and more efficiently. So can we start to glean these correlations and predictions and kind of roll them out more generally across all of our data sets? So that's a good question. So let's dive in a little bit deeper on that. So this is a geekier slide. You'll notice the slides get geekier and geekier as we go. So hopefully you guys, you know, we'll inject you with caffeine or something if required. But basically, you know, we've got a scenario where you've got, you know, city A, city B, city C, right? So 3 different cities, all of them have crime data. You look at the data, and, you know, there's like somewhere in there's a timestamp, somewhere in there's like, you know, where did the crime take place, and then there's stuff like, you know, is the ticket open or not, and then there might be sort of, I don't know, stuff unique to the city. But somewhere in there, if this is really crime data, is the actual crime that took place, right? And so one city might call it crime category, another might call it crime type, yet another criminal incident. So the challenge becomes like, how do you make it, you know, how do you notice that it's just crime type? And so we've got, you know, a couple strategies. And a lot of the kind of communication and talk is around top-down strategies, where somebody defines a schema, and then everyone kind of tries to adapt to it, right? And this is a very noble and valiant effort, and to the extent that these schemas exist and get implemented, that's fantastic, and we'd love to embrace them and use them and all that. And we even go further with this top-down strategy. We build apps. So for those of you who've used our budget and spending apps, we're out there, we've got a schema, we're trying to kind of get folks into this. But we recognize at the end of the day, not everyone's going to get into the common schemas at the rate that we need them to, and not everyone is just gonna get there. So we need to have another strategy that also sort of moves from the bottom up. So we can automatically go after data sets, automatically start to mine them, and figure these kinds of insights out at the same time. And hopefully one day we sort of meet in the middle where all data lives in a happy land. So what is it that we're trying to do? So you'll hear me talking a lot about annotations, but basically we've got this, you know, this data set. And so for the, you know, you can imagine it as like, you know, a spreadsheet in Excel if that's you know, the most intuitive way to think about it. But basically it's a bunch of tabular data, right? And for those of you who are amazing open data practitioners, you take your data sets, you think about them very carefully, you tell us exactly what's in them, you give us the, you know, the title, like nice, meaningful column names. Each column, you know, tells us exactly what's in there. This is, you know, crime type, this is a point, this is a whatever. And that's fantastic. You might give us the title of the data set, the tags, you might tell us what category is it in. Hey, this is about infectious disease, or this is about, you know, bicycle a data set. And that's amazing, and we love you for it, but unfortunately for every one of you, there's like 3 who don't. and of those who don't, you know, even the data set we saw yesterday with the lizard entry, I gotta say, that was a beautiful data set, because it actually told us it was about lizards. Because we've got data sets that have, you know, that have maybe a whole bunch of points in them, but they don't even tell us, all the column names are cryptic, there's no title, there's nothing. So what do you do with that? That's the other end of the spectrum. So you've got lizards and cryptic stuff on one end, and then you've got, you know, folks that are doing just amazing bang-up jobs. So our challenge is to like automatically understand as much as we can about the data sets so we can do a few things. One thing is we want to feed back to you. You know, so you're a curator, you're an ingresser, you're pulling the data into the Socrata system. We want to we don't want you to just stare at a blank text field, right? We're going to try to help you out a little bit. Now, if you've already figured it out, fantastic. We're not going to override your stuff, and we're going to make sure that the curator's helped out. But ultimately, that's what we're going to do. And if you gloss over and fall over, and you know, and just hit next, we're still going to take your data. And we're gonna and you're gonna be rolling with whatever the machines say. So that's you know, unless you say you don't want that, in which case we'll override it. So what are the things that we're doing? Data set categorization is one. We need to figure out, what's the general category of this data set? Is it about health? Is it about waste management? Is it about transportation? If it is about transportation, what's it about? It's about taxis, bicycle data, etc. So being able to have these categories is important. Again, you're trying to build an app. Maybe you're building an infectious disease app. In Atlanta, Georgia, being able to figure out that that's where the data set's from, or getting the right data sets is important. And I'm going to dig into that one in particular because that's where we've actually built some models, and I'm going to walk through some processes there. Another one, yesterday SAF demonstrated taking a data set and linking it up to maps. Stuff, some of those data sets never had a map in them, right? So imagine you have a data set, it's got all of the locations, point data of where bicycle racks are located in a city. In the city of San Francisco, let's say. So, presenting maps of Chattanooga, Tennessee to somebody whose data set is all sitting in San Francisco is obviously not a great idea. And so that's an egregious example of what we need to do. But we need to get even smarter. We need to figure out, well, what exact maps are relevant. So being able to take that spatial boundaries of those points and kind of align those with the right maps, in a repository where we have lots of maps, right? So we're building up this whole knowledge base that's got, nation boundaries, county boundaries, city boundaries, police district boundaries, school district boundaries, etc. And being able to pick the right ones is important. Column normalization we talked about with the crime type normalization. Another area is entity detection. So, a lot of the data sets have just columns of stuff in them, like a whole list of people's names, organization names, department names. So being able to automatically figure out, that's what something is in a column of data is really helpful, right? Because if we know that, this column of data is a bunch of, country names, well, then we can do something a little bit more interesting than just throw up a bar chart, with country names, right? So for example, the UN development program has a really great data set where they tell you, so each row in the data set is like, I'm simplifying, but it's, country, like the name of the country in a string form. It's the amount of money spent and the particular project that it was spent on. Right? So one way to take this data is to, first thing you need to do is, we go through this kind of, we're building these models for aggregation association. So one of the things is like, hey, how can we look at this data in a more intuitive way than just a big table, right? So one thing is like, hey, maybe we're just interested in the total amount of money that the UN gives to a country, period. So we need to be able to associate the country name with the sum of all of the projects, that are in that data set. And that's, one activity. The next thing is like, hey, instead of throwing it into a bar chart, can you guys hear me, by the way? Okay. Yeah, instead of throwing it into a bar chart, wouldn't it be cool if we automatically now perform some location association and understand that the names of those countries are actually regional, and figure out the actual spatial boundaries so that we can throw them on a map. And you pair these two things together, and all of a sudden you can have a nice choropleth map, where you've got a map and you've got the actual total amount of dollars spent. And if you click on that dollar spent, maybe you get a little window pop up or something that tells you exactly what the projects were and exactly how much money is spent. Much more intuitive, optimal user interface. Ooh, I wasn't expecting that. Here we go. So the next question is, how do you get machines to learn stuff? So, so this is let's take a little detour here. So there's an area of machine learning called supervised learning, right? And in supervised learning is just a fancy way of saying, hey, learning by example, right? So in the same way, that you might take a human, like a child, and a parent might point to a chair, it might point to a stool, it might point to a sofa and say furniture, and the child's learning through example. We have a very similar technique with machines where we point to one data set and we say health and infectious disease, and we point to another data set and we say transportation and taxi related. The more sort of examples we give it, the better the machines get at classification. Now it turns out, just like humans, machines, the more knowledge you have ahead of time, the better you can do. So given the exact same amount of training data, if you have more knowledge, you learn more. And this isn't counterintuitive to us. And so how many of you guys, then this is a very revealing question, read the Odyssey or the Iliad or sort of one of the Greek classics back in high school? And if you didn't read it, you can just lie and raise your hand. It's OK. So back in high school, when you read this text for the first time, you had some kind of vocabulary. It was probably a little bit less than you've got today, right? But you knew some stuff. Maybe you knew a little bit about the world. Maybe you saw a map of Europe and you saw the nation of Greece and kind of how it rolled out. Maybe you understood, kind of, I don't know, on some intellectual level, the temperature of the Mediterranean, et cetera, or the Aegean Sea. And you had some kind of experience with humanity and how people interact. And you read the text, and if you stayed awake and paid attention, you gleaned some insights from it, and that's a great thing. Now, fast forward 15 or 20 years, maybe you went to school, maybe you went to college, maybe you got a decent job, maybe you went to Greece on a vacation in the summer, maybe you hopped a boat from Athens to the island of Naxos, and maybe you grabbed a moped and drove to the top of Naxos, and you actually saw where Zeus, was given his lightning bolts, and you were actually there, and it was a black cloud, and it actually was lightning there, and you saw some weird-looking goats with like blue eyes that stare at you on your moped ride on the way up. And you look out over the Aegean Sea, and you're like, oh my God, this is like amazing. It's green, it's like vivid, it's lush. And and of course some time's passed, and you learned something in college, and you read some books along the way, and your vocabulary is a little bit bigger, and you've got a little bit more geographical understanding of the world. And now you go back and you read the Odyssey. And now you get some more insights, right? You get a little bit more than when you were back in high school. You go back and you learn more. And it's very similar with machines. Machines with more knowledge learn more from machines. And this is sort of a nice virtuous cycle. Like we get more knowledge from more humans who go to places like Wikipedia and tell it things, or who go out and join universities like Princeton and build projects like WordNet. And then we get more knowledge, and all of this kind of feeds into one another. So let's anchor it a little bit more specifically. So we've got, what is the knowledge in our system? It's spatially based. We've got topical-based knowledge. We've got linguistic knowledge. From a spatial standpoint, we're taking in things like GATM, the census data, plus like city, regional boundary data, police district, school district, et cetera. Topical information, we're pulling in things like from Wikipedia, where there are millions of people, places, locations, et cetera. And we're bringing that all into the system. We've got language data, where we learn kind of definitions, synonym relationships, hyponym relationships. All this stuff kind of helps us build out knowledge base. And then meanwhile, we kind of seed the system. And this is like a virtuous feedback loop that we're queuing up here. We seed the system with some data, and we go and we build models, right? No machine learning talk is complete without a picture of a brain. So we have a picture of a brain here. So we take the knowledge, we take the data sets, and we kind of bootstrap the models, right? And so we've got a couple different types of models. We've got deterministic models, which is just a fancy way of saying kind of rule-based models, which is like, so if you think about a child that walks up to a hot wood stove and touches it and says, oh, that was hot, The brain's pretty simple in that scenario. It says, okay, don't walk up to hot things and touch them. But we've got, and in our case, we've got some simple models like that, right? So being able to, automatically leverage some semantic web techniques where we can go through DBpedia and mine things like Wikipedia and be able to rapidly put together like 25, 30, 40, 50,000 human names, and now look at a column of data and say, hey, more than whatever, n% of that data, of that column is a human name. That's a good enough model for that. Like, works pretty well. But we've got some fancier models that sort of are more example-based, that use things like support vector machines and gradient boosting algorithms, and are able to kind of take things, and we're able to kind of figure out how accurate we are, et cetera. And they're able to much more refined learn. And classification of data sets is a good example of those. Then we take them and we crowdsource them out to millions of people located all over the world. How many of you guys have heard of Mechanical Turk from Amazon? Okay, a few folks in the audience. So there's a product that Amazon puts out called Mechanical Turk. There are other ones out there as well. But the general idea is that millions of folks located all over the world log into their web browser and perform incredibly inane tasks for incredibly modest amounts of money. But they do it because maybe they're working at a swimming pool and they're bored. Some people find it fun. But the classic example is you take an image, you throw it up to a bunch of humans, and you ask the human a very specific question. Tell us what's in this image. So human 1 says ball, dog, beach. Human 2 says ball, dog, Labrador retriever, and beach. Human 3 says chicken, because they're just like a rogue, and they're just messing around. And so, the more people you get a richer idea of what's in the image, right? And then you can take that and you can build stuff like, you can go and search through it or do whatever you want. So it's a way for us to have these microtransactions with humans and in very rapid ways be able to get annotations. So we go through there, we get some annotations, we feed those back into training data sets, we get a little bit more training data sets and we feed them through, we get better models that learn more, we get some of that stuff, we feed it back into the knowledge builder. Meanwhile, you guys give us more information, the whole we hit this virtuous cycle of increased knowledge. So let's anchor the conversation in something even more specific. Let's talk about one very, very specific scenario. So we wanted to build data set categorizers. So we took a curator, in this case it was me and a couple of cursed interns who got to spend a few hours, actually a day, just staring at data sets. We took about 850 data sets, we looked at them and we annotated them. We said exactly, well, this one's health and, and this one's about waste management, etc. And we build what we call a gold ground truth, because after all, we don't trust anyone as much as we trust ourselves, right? And so then we said, well, gee, I don't want to do this anymore. I'm bored. And the interns, they're computer science interns, and so the logic was pretty simple. If you're a computer science intern and you spent, a day annotating some data sets, you'll probably never bother to mention it to anyone. But if you spend 3 months sitting there every day annotating data sets, you will definitely go tell everyone at your school, and no one will ever be an intern at Socrata again. So then the question is, well, what do we do? So we took these 850 data sets that we thought were perfect, and we farmed them out to Mechanical Turk, and we got people we don't know at a penny a pop to tell us what was in these data sets. And then we said, well, how accurate are we? So because we can measure them against ourselves, and we found out it was around 90%. We'll get a little more detail in a second. But now we said, okay, we got 850, we got this machine, so let's turn the crank. Let's go from 850, which took us a day with a couple folks that definitely don't want to do this again, and then in about an hour with around 5,000 data sets, we were able to get all the stuff turned around really quickly. So now we got a lot more data. We feed that into our models. We train up some models. We're able to assess how accurate they are. And the way, common technique in machine learning is you take all this data that you now have these examples for. You grab 80% or so. You train up on those, and then you test it against the remaining 20%. You see how accurate you did. You kind of do this with different parts of the data sets, and you're able to get some annotations and understand how well you did. So with that, I'll show you a quick demo. So this is a prototype, so please don't laugh at the UI. But it does give you a flavor for what we're gonna. Where is my browser? Ah. All right, I don't know why it's rendering so oddly. I can't see my mouse.
You should have it down in front of you, too.
Yeah, I don't. I can't get a mouse. Oh, there it is. All right, great. So here we've got, so we took these models now, we ran them against a bunch of our data sets, and then we also ran them against, sent out a crawler, and we grabbed a bunch of other open data sets out there on the web, and we pulled them in, and we sort of classified them at a high level. And so you see, from here that you get kind of an understanding of, at a high level of some of the higher level categories that we built. So we click into one like transportation, and this is all live. It's hitting our servers back or up in the cloud somewhere. We now have, transportation related subcategories. And again, this is still early data, so we don't have like every possible category built out yet. But we've got a few. And so now we can drill into something like transportation, taxi-related information in transportation. And so now we're sort of quickly able to kind of hone in on the actual data sets. And so you can see that you've got like different levels of confidence because these algorithms are able to kind of assess. We can go back to the deck now. So we can see that like you have different levels of confidence and we're able to kind of rank things appropriately. So then the question was like, well, hey, how let's before we get to the machines, we first ask ourselves, well, how well did the humans do? So not the interns and me, but the other humans that we went out to Mechanical Turk on. And you see this relationship here, which is pretty interesting. It tells us that roughly 85% or more of the humans agree. So if you farm this out to a bunch of humans, and if I guess a supermajority plus agree, you're sitting at really high accuracy, around 100% accuracy, or so. Once you get down to around 70% of the humans agreeing, you kind of drop a little bit. You're around 95% accuracy. But you see that as the humans disagree, and that's because, again, eventually you wind up with the data set that has a bunch of cryptic columns in it, and nobody knows what the heck's in it, and so everybody's disagreeing. So how do the machines do it? Well, machines also have a trade-off. So when we're looking at around 75% of accuracy, we get 100% of the coverage of the data. That means we can just take the models and apply them to anything. The flip side of that is if we only apply the models, because we have a confidence assessment, if we only apply it where we know we're incredibly good, like 100% accuracy, then we can cover about 20% of the data set. So if we have 100 data sets, about 20 of them will come out with classifications. And if we pick a sweet spot somewhere like around 90% accuracy, then we can cover about 80%. And then we can sort of judiciously allocate our resources and say, OK, well, the rest we're going to go ahead and send off to the humans. So another thing that's kind of related to being able to glean insights is in an enhanced user experience is being able to do so rapidly, to be able to have things kind of respond efficiently. And as many of you guys know, there is actually no magic database that covers all data queries and sets. So databases tend to break up into different categories. We've got spatial ones that are really good at doing kind of mapping types of queries, tabular ones, temporal ones. There's some that are just really tailored towards doing searches. And at Socrata, we have kind of all of the above, right? And so one of the things that we need to be able to do is route things appropriately into the appropriate database structure. So for example, if any of you guys have been, everyone here has probably been on Google, and you type, and as you type, very rapidly in sub 100 milliseconds, you're getting kind of auto-suggested queries coming up and popping up. And so that type of index structure is really important for being able to rapidly look up things like people's names, titles, employees, and that sort of thing. So here's kind of an example of how because we can annotate, we can automatically recognize whether somebody's a person, a place, an organization, a thing. We can now route it to the appropriate dedicated cluster out in the cloud of Elasticsearch indices that have a dedicated structure on them, and we're able to kind of serve up those results incredibly fast. So what can you do to make the product better? Well, in the same way that Google is able to trounce all their competitors because they ultimately have the best or the greatest volume of examples, right? Every time you go to Google and you do a search and you click on the number 8 result instead of the number 1 result, and you go to that page and you stay there for a while, that tells Google, oh, number 8's actually really good and number 1 was not the right answer, right? At least for that user. And conversely, every time you click on 1 and you go there and you bounce right away, that also tells them. And so that's what we're gearing up for here, is we're taking our product, we're building in more and more feedback mechanisms in so that both you as a publisher and the citizens and their usage, the stuff that you do tells the system how to make it better. So when you're ingressing data, you're going to start to see more and more of this. So you're going to see, for example, hey, we think this data set is about infectious diseases. Now, if you tell us that's wrong, great, the system gets better. And if you tell us that's right, great, the system gets better. But if you tell us nothing, the system doesn't get better in that case. We don't have another data point. So the usage is important. Spatial boundaries help. Many of you are have the ultimate understanding of the stuff inside of your areas, your counties, your cities, your states. So you know what the school district boundaries are, you know what the voting district boundaries are, et cetera. So when you put that into the system, we can take that now, and for all of your data sets, we can enhance it and offer a better experience. And if you make it public, we can enhance it for everyone else as well, who's using both your data sets or has their own data sets that kind of overlap with that. They might be doing something at the national level or the state level, and maybe you had city data or county data, and it's all going to make it better. Citizen usage, meanwhile, when citizens go to things that so if we heard a great talk yesterday about being able to take data and provide sort of an optimal visualization for it. A designer, however fantastic they are, it can do a great job of making something look great and put a fantastic hypothesis on the ground. but it's not going to be quite the same as being able to take a population of, say, 10 million users, having seen that graphic and behaved and interacted with it. They're never going to be able to do that. So one of the things we want to do over time is be able to take that population, that deeper insight, and be able to bring that back to you and tell you whether or not that was the right view, or how to tweak it, or to how to ultimately we want to automatically generate those views and say, hey, this one works great for this class of data in this particular scenario. So basically, use the product, provide it more data, it gets better. Questions? Don't ask me anything about the Odyssey either.
Hi, thanks for the great talk. So there has been for about more than 10 years a metadata standard around called the Data Documentation Initiative for social science type data mostly. And I'm wondering, is it already possible, or are you considering allowing to import metadata in that format into Socrata if a government agency already has a data catalog that supports that standard, so they don't have to recreate the metadata when they migrate to Socrata?
Yeah, that's a great question. And I'll even kind of generalize it a bit, because there are other standards for other classes of data. And I think our strategy is, again, wherever there's a top-down initiative that has some traction, to write connectors or mappers to kind of map that into our internal structure. We're not trying to like usurp any kind of top-down knowledge. To the extent it's there, fantastic. We'll take it and we'll run with it. Yeah.
Are Socrata users going to be able to see the confidence ratings of data sets? That's great feedback for us in terms of structure and like data sets we need to obviously make better to make them more discoverable.
So the question is whether we're going to make available the confidence in a given classification. Yeah, I don't see why not, right? I mean, I think the more data that we provide, the better. It gives you the chance to decide whether or not, to filter it appropriately. So, yeah.
How are you guys doing?
How do you handle privacy? And because one of the concerns a lot of people had about privacy, and especially if you go to Europe, that'll be a big issue. How do you guys handle all this learning and in the data itself?
Yeah, I mean, so far we've only been working with public data sets for this analysis, but it's a great question. I think in general, data that's private, to the extent that we learn against it, I think. Actually, I haven't thought that one through yet, but my sense is that we need to go back to you and say, hey, is it okay if we glean insights from your private data to apply publicly, and we need to get explicit authorization from you. I think in the majority of cases that the folks will sort of want to know more, and so my intuition is that that's probably, it's worth it for us to just learn off the public data sets starting out. Okay, well, thanks a bunch.